afternoon. Hope you're having a great day. And you know that this is the talk where if you do the survey and give me good grades, you'll win the raffle. So that was just to wake you guys up. Okay. So I want to talk a little bit about the story behind this a little bit, because I was part of the original definition of Agilex 5. And a few years ago, a few of us, 3 of us in this building, I think we're going to rename that room Agilex 5 room. We used to argue on a lot of different things. And one of the key things that I wanted to do at that time was, how do we improve our processor subsystem? How do we enable efficiency and scale of performance around that, right? So we're trying to talk to you about that today. So I'll go to the first slide. Just a little bit about the talk. What we want to do is I'm going to talk and look at opportunities to solve some of your biggest challenges, right? So we're going to talk about where are the opportunities, and then we'll talk about what have we done to solve those challenges. We'll talk about new features and capabilities in the processor subsystem. We'll also talk about the efficiency and performance gains that we've developed, and then we'll walk you through a couple of applications which will showcase some of the performance and application gains that we've derived from that. So that's kind of the flow of the talk. Before we get into it, I'd like to get a poll from you guys. If you could take out your phones and give us a little quick survey. Tell us, where your biggest challenges are. I'm going to walk out of your way here so that you have a clear access to the QR code. If you could tell us, from a quick survey, what your biggest challenges are. I'll give you, a few seconds to kind of work it. If everybody's got it, move forward. Okay. So interesting. The survey results are interesting. You're kind of so I see a kind of a tie between application performance and power and ease of tools and application development, and kind of your close third is your flexibility and scalability. So we'll talk a little bit about all 3 areas, right? One of the 3 things that I think you guys have highlighted is application performance and efficiency. So one of the things we did is we wanted to make sure that we had a more modern and advanced architecture. So we're coupling up, the latest ARM cores, at that time with a fabric, which is the highest performing fabric in the industry. So it gives you that advanced architecture to be able to develop your performance at your application at scale. The other thing we did was we put in a diversity of cores. So you're able to kind of scale your power and performance across your application, right? Needs, depending on what the needs are. The other thing that, as you will see later in the presentation, we have enhanced our design tool support. So there's a lot more tools and ecosystem compatibility. We'll cover that. I think some of that was covered in the previous as well. Then the last thing I want to talk about is applications. How do they take advantage of the architectural flexibility? And things like, how can you optimize the hardware and the software at the same time, right? How do you do workload consolidation of your workloads? And then lastly, how do your solutions, make them performance and scale them across performance and cost targets, right? Which is a common theme for a lot of our customers is application scalability and investment protection. I want to build my application once and then be able to scale it from various regions essentially with the same architecture. So this is bent as a bit of an eye chart. I wanted to showcase this to you. This represents a lot of hard work from a lot of people to put this together. Not the slide, but the actual product. The key thing here is that, and I'll cover this, is that it is a grounds-up development, right? It's not something that we've reused from one of our older products or something. It's a brand new development with new modern cores from ARM, and an integrated and upgraded peripheral subsystem. I was just talking to somebody that said, you've been not offering enough peripherals. So that means that we have more work to do here. So it's basically saying, and then we have used the ARM Dynamic IQ shared unit as well to kind of help with the caching and the performance system gains there as well. So I'll talk a little bit more detail about the processor cores itself. It's a heterogeneous mix. It's a big little, ARM, I know called it big little. So we have a quad-core setup. It's a dual-core ARM A76s and a dual-core A55. and which gives customers the ability to, based on their application needs, to trade off between high performance and lower power. Power was one of the things that we did work on a little bit more than what we had done previously. We have added static power alignment, so you're able to turn off unused cores. Various configurations of use, you can turn them out to save power. And then, of course, I was talking about the dynamic IQ shared unit, the DSU, with L1 and L2 caches and a shared L3 cache with Snoop control. And of course, we support the ARM core side debug capability in the product. Looking at the peripherals, so we've made significant upgrades. We are now supporting USB 3.1, both device and host controller modes. We have I3C. We've added I3C, which both one configured as primary, the other as secondary. And we have 3 Ethernet TSN Max that support full TSN endpoint functionality. The other thing that we've done is we've updated the DMA controllers. The DMA controllers are 4-channel capability, and they support both secure and non-secure accesses to the HPS resources. And of course, NAND flash and SDMMC have all been upgraded to the latest and greatest. I want to talk a little bit about how the heterogeneous clusters deliver scale and diversity of performance, right? If you look at that graph here in the back that we have, you can see on the bottom we have performance spec-ins, and in the vertical we have power in milliwatts. Each of those lines indicate a performance of a single or dual or a quad core, and the lower performant one is basically when we run the processes at the minimum frequency, right? So there's a frequency scaling, and the blue line is really where you're looking for power optimization. My performance needs are low, so I could run an A55 or something and boot up an RTOS on it or something, which is safety critical application. My performance needs may be different, so I could do that, or I could go to the top end, which is your number 10 there, if you put, which is when I need a lot of performance in my application, where I have algorithms that I'm running or something else, right? So it really, if you look at the curve, you have the ability to kind of go in and chart your way across the performance and power curve, right? You're basically able to see where you want to go, right? So that's what the ability to have these cores and run each one of them can be tuned individually at different frequency points, so you can actually tune your application that way and power optimize that way. In terms of the other thing that we have is the quad core setup that enables is you're able to now have diversity of OSs and provides the architectural flexibility for you. For example, you have SMP Linux, which you can boot on a single core and then offload other tasks to the other cores, or you could take a hypervisor and boot each core with different OSs. So you could do either of those. That flexibility is available and is available for you. So I want to talk about one other, or actually 2 other features that we added that supports high performance systems, right? So we support cache partitioning. Cache partitioning is really around, can I partition my cache so I avoid cache starvation? If one core needs more memory, so I can partition it equal and distribute it based on the application's needs on how much cache each core needs. And what this really does is it gives predictable performance and behavior of the cache system, so that you don't end up starving one core versus the other. If you see in the example there, we have core 1 and 2 that have individual partitions. They actually are sized for their application requirements. Core 0 and 3 are sharing a partition, and their access patterns are similar, and it's more efficient to do it that way. So you have full flexibility in terms of how you can partition your core is based on application needs and stuff that you could do. The other thing you could do is, in order to save power, if your cores are not active or if you don't need the full cache, L3 cache, you can turn off half the cache and save power that way. So that's another way to save power. The other feature that is available is cache stashing, and it's ready for data transfer efficiency. Cache stashing allows the FPGA fabric to directly write to the cache lines of the processor subsystem. So you can directly write to it, and you can make the data that you're using the most critical data, to be most efficiently handled by the processor, right? So you basically enable the application to be able to access the data in a much more efficient manner. You bypass the main memory, essentially for it, right? So that feature is also available, for in Agilex to use. So we've talked a little bit about what the basic capabilities of the system are. I wanted to just walk you through some applications. I have 3 applications that I wanted to walk you through. The first one is a scalable image path. And really what we're doing here is that a discrete, if you look on the left-hand side, you have a discrete CPU with the discrete FPGA coupled. And we all know CPU life cycles are short. You have to constantly upgrade the CPU life cycles, if you want to get more performance out of it. And really, I think what we've done is managed to fit it into an Agilex, which is an integrated, processor subsystem with an FPGA fabric. Now you get the 15-year life cycle with that. You're able to now optimize hardware and software a lot more easier, and you can do workload consolidation. The other thing that may not be as obvious is that you're able to save costs because of memory consolidation. You can do memory consolidation because now you don't have to have an FPGA memory and a CPU memory. Single memory can suffice. So it makes your application development a lot cleaner. The other thing that you can do is, because of the ability to be on the FPGA, you can scale your application design. And I'll show you this in the next slide. The middle slide is your current application design. It's an Agilex 5. What you can do is, if you need higher performance, you can parallelize your image path, right? So that you can maximize your image processing throughput. And you can go to a slightly larger FPGA. Or if I want to save cost, I can go to an Agilex 3-like platform, and you not only save the cost of the FPGA, but you also reduce your memory footprint. And yes, performance will be less, but the idea there is that you want a lower performance point, but at a lower cost point as well, right? So the cost is the most important thing there. So you're able to scale it within this. You can migrate your designs up and down the hierarchy of the FPGA, and you're able to kind of scale your application there. So that's really the most important part on this, is the scalability here, and allows you. That 15-year life cycle allows you to make these choice points at later point in time as well, without having to do a bunch of work on your system design. Okay. So next one I want to talk about is the Agilex capability as a ROS2 based single chip robot controller. It's a very interesting application. With the ROS control interface handles the interaction between the ROS framework. So as you can see in the picture here, the ROS framework or the ROS2 OS is running on the processor subsystem on the HPS, and it works. So the ROS control interface now works with the NEOS, which is actually in the FPGA fabric, the NEOS 5 controller, so the NEOS 5 is actually controlling the 6-axis drive, and it actually works with that NEOS to interface between the two. So you can send all your commands from the ROS2 framework to the NEOS to control the axis. The high processing, now because of the quad core nature of it, you can actually run a lot of your Movell 2, which is your path planning, and your stomp motion planning algorithms on the processor subsystem. So you don't need an external processor or something. You can run them on this. The Movell 2 based path planning algorithms will provide necessary stream of data, so for the joints to move right on the robot, right? So it goes through the processor. A bunch of commands are sent through the ROS control interface into the NEOS, and the NEOS then controls the actual axis of the movements. So that's kind of how it's done. At the same time, you're running safety applications on this. So you have a processor that is dedicated, processor that runs safety code with a diversity of safety applications that you can run on this. The other thing that you do is that because of the integrated TSN, now you have a way to control external or synchronize to external devices like belts or other things, right? You may be in a factory setting where you need to control and synchronize different time of events. So the TSN allows you to do that. And then you're able to kind of closely optimize any hardware and software partitioning and workloads and optimize it between the FPGA fabric and the processor itself. So it's a pretty cool application here. The third one is basically a soft programmable logic controller. And this is really saying it's a soft PLC. Whereas the Agilex the HPS is actually running a containerized open PLC runtime. with the drive control the same way as the previous one is running on the Neos 5, right? So you have a containerized OpenPLC running on the process subsystem, and then that controls the drive control of the Neos, right? And again, some of the key benefits are you're able to run complex multi-axis OpenPLC containers on high-performance cores. It's able to handle that. Multi-cores with cache partitioning enables multiple containers with core infinity, so you can have multiple containers running on this as well. And the integrated Ethernet allows the ability to control all your drives as well, right? So you got a complete benchmark of you've got your containers running on the processor subsystems. You have and that controls the Neos 5 for drive control, and then you can actually enable multi containers running on the multiple cores and with core affinity, and then you can control the integrated Ethernet with the ability to control drives as well, right? So this is a fairly interesting soft PLC kind of application. I've talked a lot about the hardware side of it. I'll give you a little update on the software side. I think it covered some of this was covered in the previous talk, but in general, we've updated latest editions of the bootloaders, latest versions of U-boot and ARM trusted firmware updated. Of course, the mainline Linux mainline and the LTS kernels are updated to the latest. Additional operating systems are being enabled on Agilex 5. VxWorks, FreeRTOS, Zephyr RTOS, Bare Metal, and SolidOS. We're also supporting the Zen hypervisor, which is a Gen 1 hypervisor, and a new UI to the Yocto project builder tool. In terms of debuggers, of course, the ARM Development Studio. But I think the biggest thing that I think we just learned was about the Ashling core debug environment, right, which is becoming more of a problem as we go into an ARM and a RISC-V environment where you have a Neos running and an ARM running. The ability to core debug those becomes really important. So that's what the Ashling allows you to do. And then we have the Jet to Bigger and the Lauterbach tool chain, right? So everything has been updated or new in this environment. So lots of new stuff here. At this time, I wanted to introduce Yatin Patel from Wind River. He's the Director of Project Management for VxWorks. And you've learned a lot about how the hardware is and what tools we support. But Yatin can talk through how VxWorks porting process works and the benefit of it. So welcome, Yatin. Very happy to have you here.
Nice to be here. Hi, everyone. Hi, everyone. This is Yatin Patel from Wind River. We have the next slide, please. Yeah, thank you. So yes, VxWorks is enabled on the Agilex 5 platform. Wind River also has done on other platforms as well as Agilex 5 a port of the ROS2 framework, this is available on VxWorks as you normally purchase it. But there's also Wind River Studio, which is our cloud app offering, through which you can exercise VxWorks development in a CI/CD pipeline, and the ROS2 is enabled in that form factor as well. What we've done is provided a ROS2 build environment, which will enable you to do the applications on it through multiple different means. The ROS2 is available on the Agilex 5. The Agilex 5 recently supported in Wind River. So VxWorks, a little bit on the right-hand side about VxWorks. VxWorks is the premier real-time system, quite well adopted in the industrial space. Traditional values of real-time performance and safety certification is something that we have done multiple times over in many different hardware platforms. So whether you're talking about on-prem, traditional embedded development, or in a cloud recently, it's supported on both form factors. Adil?
Thank you.
Thank you.
Thank you, Yatin. Thank you, Yatin.
Yeah.
Thank you so much. Thank you so much for coming. Thank you. So now, I'll just try to wrap up here. So in general, I think we've learned a lot about what is in the hardware for Agilex 5 and kind of discuss some of the tools and what Wind Rivers provides as support. Basically, I would just want to recap what we just talked about, right? So I think from a workload perspective, I think Agilex 5 enables hardware-software co-optimizations. You're able to do that because of the integrated CPU and the high-performing fabric. You can download. We talked through a lot of the use cases. You can download some of those use cases from our internal website and applications and as reference designs. And I think we've learned a lot about the ecosystem support that we've enabled. So would love to get your feedback on the session itself. And you know that if you do this survey, you're likely going to win something. So.
Altera, accelerating innovators.